Welcome back, class. This is your Catia mentor, and today we're going to go over how to insert symbols and apply GD&T to your drawing. Alright, so let's start by first defining our datums. So I'm going to take the base of our front view or section AA view, and let's first give this a flatness callout. So go to Annotation tab, go to Geometrical Tolerance command, and I'm going to click at the base. And I'm going to give it a flatness callout. And I'll give it a flatness of 0.005 inches. And OK. And I'm going to use my handles or manipulators here to adjust it. Now, if you don't see manipulators or handles on yours, you can go ahead and click here, go to Preferences. And you're going to go over to the App Preference. Go to 3D Modeling. Go to Mechanical Systems. Go to Drafting. And then here at the handles, you can turn on all these options by clicking. You don't need to turn these on. When you're creating a dimension, sometimes these handles get in the way as you're generating a dimension. So once the dimension is generated, then go ahead and use your handles. And OK. Okay, so I can use my handles, as you can see. Alright, so now let's add a datum A to the base. And now we're going to make this our datum B, but let's first give this a tolerance of perpendicularity with respect to datum A. So let's make this perpendicular to datum A. And let's use our handles. I'm going to grab this, put it on the right side, and extend it. Okay, so this will be our datum B. So let's go ahead and insert our datum B. Okay, so once again, our datum B has been defined, and this vertical wall is perpendicular to datum A within 5 thousandths of an inch. And for datum C, I'm going to pick the axis of the hole. Okay, so let's add first a dimension. Now my settings are set to American National Standards, ANSI or ASME, American Society of Mechanical Engineers, but it defaults to feet. I haven't figured out yet how to change this to inches, so I'm going to do it manually. So if I want to make changes to a dimension, I can, first let me show you the long way. I can right click Properties. I can go to Value, change it from feet. So the little dash tells us feet. We're going to go over to inches. Let's go with 3 decimal places and apply. There it is. And let's go ahead and use a little handle on the dimension line. Little extension. Apply. There it is. And I'm going to remove one of the arrowheads, so I can remove one of them by clicking here. And OK. There it is. Now, I forgot to add a tolerance. So let's say a shaft goes into this hole, so we need a tight tolerance. So I'm going to right click Properties once again, go to the Tolerance tab. Let's give it a limit of high and low. For the upper value, we'll leave it at 1.5000, so let's leave it at 0. For the lower value, we're going to remove a thou, so we're going to go minus 0.001 thou. and apply. So notice it's 1.500 minus 0.001, which gives us 1.499 for the low limit, and the high limit is 1.500. Okay. Okay, so now let's add our GD&T feature frame here. Let's give it a positional tolerance with respect to datum A and B. Okay, so the position of this hole, or the axis, I should say, of the hole will be with respect to datum A. So we're going to need a dimension from datum A to the center of the hole. Now, instead of having to go right-click properties to turn this into a basic dimension, I'm going to turn on a widget here. I'm going to right-click, display, object properties widget. I think it's called a widget. And let's go ahead, and from here we can go ahead and change this to inches, give it 3 decimal places, and add a frame around our text to turn it into a basic dimension. So anytime an inspector sees this dimension, they'll know, oh, okay, instead of applying a tolerance from the title block, let's say a plus or minus 10 thou or plus or minus 30 thou, instead they'll look for a frame, and there it is. This is the tolerance, 0.005, applied to this dimension. Alright, so let's go ahead and attach the datum C to this frame. Okay, so datum C is the axis of the hole. Alright, so let's apply tolerances to these 4 holes, and then we'll apply a tolerance to the slot. Okay, so in these simple holes, we're going to have dowel pins. So these need to have a tight tolerance. So these will be interference holes. So friction will be holding the pins in place, and this will most likely be attached to another part, located to another part using these dowel pins. So let's add a tight tolerance to these holes. Let's go with inches, 3 decimal places. And we're going to do the same thing. We're going to apply a tolerance, so we can do it from here. A high and low limit. So I'm going to change this to 0 for the high. So we're not going to change the high. So currently it's at 0.500. Let me click away just to show you that it is at 0.500. So once again, for the high, we'll go with 0 slash minus 0.001 for the low. So it's going to subtract 1 thou from the lower limit. Click away. So I subtracted 1 thou. Okay. And let's add a extension. And click away. Now I still have those 2 arrowheads. So I think here I have to go the long way. I'm going to go right click properties, dimension line, remove the second arrowhead. Okay. There it is, 1 arrowhead. And there's 2 holes with the same exact dimension. So let's go to the handles. So if we click on the dimension, you'll see this red arrowhead. This will allow us to add text to the front, the other one text to the rear. So let's go to the front, and we're going to add a text of 2x, quantity of 2, and OK. And let's add a positional tolerance with respect to datums A, B, and C to that dimension. So let's give it a positional tolerance of, let's go with 0.005 with respect to datum A, B, and C. And I forgot to insert a diameter. .005. Let me remove the first digits. Okay, so we're going to go with respect to datum A, B, and C. Okay, so there's our positional tolerance for the center of the hole. So it's an imaginary tube with a diameter of 0.005, and that's the location of our two holes. Okay, and I think I forgot to add the diameter symbol to our first hole. Yes, I did. Let me go back and fix that. Okay, so there we have it. Okay, I think we took care of everything on this one. Let me use the handles to center this, make it look more presentable. Okay, so now let's add a positional tolerance for our counterbore hole, but first I need to add diameters. So the small hole, it's a clearance hole for a socketed cap screw, half-13 thread. So let's go ahead and leave it as 2 decimal places. It's just a clearance hole. The other one we went with a tighter tolerance, so we went with 3 decimal places. This is an interference hole. This is a clearance hole. So let's leave it at 2 decimal places. Let's add the handle or extension. And let's remove the second arrowhead. Right click properties. Remove second arrowhead. OK. And let's add the 2x. Quantity of 2. There's 2 counterbore holes. Okay, now our large diameter hole is 0.88. Actually, we may need to go a little bit with the larger diameter, but I'll just leave it the way it is to provide clearance for the head of the bolt. Alright, so what I'm going to do is combine these 2 diameters into one. So this is a counterbore hole, and they share the same axis. So I'm going to add text to this diameter, and I'm going to use the counterbore symbol, space, then add diameter symbol, space, and type in 0.88. Right, so we're going to type in the 0.88 space, and we're going to go with a depth of space 0.40. Also a loose tolerance, and OK. The depth is 0.40, and just to prove it to you, this is 0.40 inches. There it is. I can hide it or delete it. Alright, so let me go ahead and position this. And let's add a tolerance. We're going to go with the very loose tolerance on this one. Get to practice applying GD&T. So we'll do a positional tolerance of, let's go 28 thou, 0.028 with respect to datums A, B, and C. And OK. Alright, so now we need to add our dimensions. Okay, so let's dimension from datum B to the location of our first set of holes, and then we'll go to the second. So let's add a dimension from datum B to the center of the hole. Change it to inches. And let's go 3 decimal places. And we'll add a frame around it, indicating it's a basic dimension. So once again, the tolerance for this dimension are in the frames and not in the title block. So for something like this one, this would be in the title block. Alright, so let's add another datum. I should say a basic dimension. And I'm going to use the paintbrush to copy the properties of this first one. There it is. And I'll do the same thing with our vertical dimension. And use the paintbrush to copy the properties of the existing dimensions, our basic dimensions. Alright, so, oh, and I forgot to hide this 0.88. It's already here, so I can hide this. Now the proper way of dimensioning this would be to place the arrowhead on the large circle. It just looks cleaner. But you always call out the first, my mistake, the smallest diameter first, and then the large diameter when calling out a counterbore hole. Alright, so now let's add GD&T to the slot. Okay, so let's first dimension the slot. Now let's say I wanted to dimension quadrant to quadrant instead of center to center. So I'm going to right click, go to anchor. Oh, cannot find anchor, so let me do it over again from scratch. Delete. I'm going to redimension again. Arc to arc. Then I'm going to right click, anchor. First extension, let's go to anchor 4. There it is. I want the left quadrant. Right click, go to second anchor. I think it's anchor 4 again. There it is. There we have it. And let's go with inches. Let's go with 3 decimal places. And let's give a clear break there. Okay, so on this one, I'm going to give it a tolerance of plus or minus 10 thou. So let me click on this one and add a tolerance. Tolerance of plus or minus 0.01. Oh, it's not an option here. I was hoping to find 0.010. Don't see it. So I'll just type it in. Plus minus 0.010. Click away. There it is, plus or minus 10 thou. Now it's hard to see, but there's the plus, minus, 0.01. Okay. Okay, let's give it a vertical dimension. And I'm just going to copy the properties using the paintbrush of this one. And let me give it an extension. Alright, so now let's apply a positional tolerance. So we have the dimensions for the slot, but now let's say we have to position the slot with respect to datum A, B, and C. Okay, so let's go ahead and add a tolerance to our first dimension. So let's say the position horizontally is not as important as vertically. Okay, so we're going to apply a loose tolerance. So the position going left to right horizontally. We're going to add a positional tolerance. And here we leave out, actually here we'll go with a positional tolerance of, yeah, we'll leave it at 28. It's a good tolerance to have with respect to datums A, B, and C. Okay. Let's position it, center it, and it moves with this dimension. Let's make some room. Okay, so we're going to do the exact same thing for this dimension, except we're going to tighten up the tolerance. Let's make some room here. Add our feature frame. And this time we'll go with 14. A little tighter. And okay, so the position vertically has a tighter tolerance, right? With respect to the horizontal one, X and Y. So let's go ahead and add a basic dimension. Locating the slot from Datum B. And right click and let's go to anchor 4. That way it goes to the quadrant of the arc. And let's turn it into a basic. I'll use the paintbrush to copy an existing basic. There it is. And let me use the grips to leave a gap there. Let's make some room. Alright, so there's our position. We can actually also position it with respect to the center of the slot. And for this one, since it's already centered, we don't need to add our dimension like we did on this one. So it's centered about C, right? The axis of the hole. Alright, so let's see if there's another critical dimension we should add, or critical maybe we should do a profile just for fun. Alright, I'm going to do a quick profile tolerance. Let's say the tolerance of this arc was critical. It actually isn't for this example, but let's say we wanted to add a profile tolerance. So let's add a profile tolerance to this surface. And let's go profile tolerance of 0.010 thou. So that means the profile of this surface can be +5 or -5 thou, which is 0.005 in any direction. With respect to datums A, B, and C, okay. And let's place our starting point here. Alright, so I hope you liked this video. Later on I will be creating a more complex video involving drafting with assemblies and including exploded views. See you in the next video.